Hey, welcome everybody. My name's Kyle. We are very lucky to be joined today by Nono Martínez Alonso. In way of introduction for Nono, what's to say that has not already been said? So Nono Martínez Alonso is a creative technologist, an architect, a software developer, and an OG of creative machine learning. Nono, as you have already, I think we'll discuss today, and I've already mentioned to the class a number of times, developed what I think is the very first time anyone put a sketch interface in front of a machine learning model. Is that true? I've always had trouble kind of
Uh,
framing these things.
Contextually, the Pix2Pix guys released the code. Christopher Hess put interface online, and I tried to make it a bit more interactive. Yeah.
Well, when I'm trying to brag about you, no, we should never be shy about it. A little exaggeration here and there. It's okay. Certainly intended for a creative audience. This was the first. I think there was a kind of like a sketch to pick or pix to pix demo that allowed some kind of sketching, but it was not really. It was kind of more like a demo.
Hi everyone. I'd like to thank Kyle for inviting me today, and all of you for your time and for being here with me. My name is Nono Martínez Alonso, and I'm going to be talking today about something that conceptually I've tried to package as drawing by hand and machine, even though I'm an architect by training and I've done software development and tried to specialize in architecture. I actually haven't worked too much on actual architectural practice. I've focused my career into software development and building tools for other people or creative tools for self-expression. My master's thesis at the Harvard Graduate School of Design focused on the use of early machine learning generative models for drawing and art. So I kind of left aside again architectural practice. But we can all agree that in some way ideating and going from a sketch to an idea or a concept can be applied to architecture. So I'm a kind of a sort of like not super defined persona. I'll talk a bit about my the things that I do before I jump into sharing a project. And before I studied architecture, I started teaching myself programming. So even from the age of 14, I started writing websites and doing interactive things that other people could access online. But I think architectural school still made me appreciate sketching, aesthetics, and simplicity. And I don't really think I should have gone straight into software engineering or something like that. Um, when I gave this presentation sometime was a few years ago. Now it's been already 6 years that I came back from Boston. I lived there for 3 years, studied in Cambridge, and made some acquaintance at Autodesk, where I specialized in computational design during the masters and also creating intuitive interfaces in an attempt to make hard technologies accessible and understandable to other people. And as Kyle has said, I work at Autodesk as a developer and a machine learning engineer for 6 years, something like that. A disclaimer is that today all the views are my own and I'm presenting personal projects only, so nothing to do with Autodesk or my current work. And as I said before, I do many different things. It's proving really hard to define oneself today. Roles are hybrid and we kind of evolve with different interests that pique our attention. Some days I used to define myself as an architect. I now define myself as a creative coder, podcaster, blogger, a computational designer, sketcher, and a streamer. So, feel free to kind of pick words. You don't need to choose one. I can't really narrow it down. In my life, I think I emphasize trying to bring play and passion projects into work, even though it's, sometimes you need to separate because everything you end up doing on your daily job starts getting farther away from play and your passion projects. That said, I like to work with interfaces, so I try to always not express things just in code, but create interfaces. In this installation, for example, we made a touchscreen that could be used by kids to draw, and then we could show them that we could send those instructions to a robot, something that would be really complex otherwise. And also in engineering or architectural design, creating intuitive, let's say, or easy to use interfaces for something as complex as designing structures, right? Here, for example, you can just create a few bars and create the simulation of something that seems like it's a bridge or something like that. And then there are other projects. Not going to talk about this one too much, but these are just illustrations for fun, right? Like, and also things that when I lived in the US allow me to communicate with my loved ones in a different way. For passion projects, I actually would briefly mention the YouTube channel where I do things like what I'm doing today, talk about my projects, and also do hands-on development. I've been going for a couple of years, so there's like hundreds of these things online. Many of them is troubleshooting things, but many times we get fun exercises and things. And then the other one is the Getting Simple podcast, where you can listen almost anywhere. And I also am guilty of trying to professionalize it too much in the way that, if you record video, want to add transcripts, do these things, it makes it super hard to release each episode. But, here we are as well. Kyle has been in one of those. He's still not on the podcast, but he's on the YouTube channel. And yeah, so that's kind of like a 5-minute overview of some of the things that I do. And, you can write on the chat or tell me later if you have any questions about these things. So let's get actually started on what I came to talk here today. We have two parts. One is drawing by hand, and the other one is drawing by machine or drawing with machines. Drawing by hand encapsulates everything from the analog act of getting a pencil and actually drawing to like using a computer manually to edit or process these things. And drawing by machine or with machines is everything that computers can do without too much of our help. This is one of the things that I took from architecture. I've been sketching for many, many years. This type of freehand sketching style is basically getting a sketchbook, getting pen with ink or watercolor, and try to depict things that you're seeing from real life, so nothing from pictures. And let me see, yeah. And over the years, I also tried to convert this into something more than just a side hobby. I try to draw every day something and write something every day. And every week I try to pack one of those sketches with a little essay and publish it online. So at sketch.nono.ma. And, I passed through COVID, for example. I went from sketching outside to sketching at home and trying to, depict things that we can see at home. To like drawing things that relate to the hobbies that I do, for example, free diving, and also the tools and things and devices that I use for podcasting, for YouTube videos, and for working, right? So all of these sketches, as I said, are hand sketches. They kind of serve as memorabilia or some sort of reminiscent of experiences that I had, items that I owned, or places that I lived in. And as I told you, it's just basically getting a sketchbook and drawing by hand. And it's something that for somebody like me that is trying to specialize in machine learning and software development and creating digital interfaces is a really nice way to get out of the screen and actually do something analog, because these days we can do almost everything on our iPhones. So doing something with our hands is really nice. I'm not a big hardware guy, even though I'm trying to learn more, but drawing is my thing. My tools are, I bring usually a backpack, a sketchbook. I bring a few pens and a water brush, and I bring my watercolors. And that's something that in the end gets back to the computer. I sometimes also sketch digitally on a tablet, and I actually do a rigorous process when I want to either share drawings online or archive them, or maybe even create reproductions. So everything starts on the sketchbook, but then it goes to a high resolution scanner. I edit the raster images that I've scanned on Photoshop. I create PDFs on high resolution on InDesign. And with Acrobat or some other tool, I print on a high resolution printer, and I have a physical artifact. So basically, it's kind of a round trip between something that exists on the physical world makes it to the digital world, and then with some processing, it's back to the real world. The scanner is 1200 DPI scanner for anyone who cares, and I store it by sketchbook. So in some way, I'm building a repository of all the pages that I have in each of the sketchbooks. And I started doing this, and at the same time that I was working on machine learning, and each of these sketchbooks in some way has a huge data set of places I've been, things I've owned, things I care about, and even some snippets of text, right? So these are all timestamped. They have some label, and they're a lot. I mean, if you draw one thing every day, you'll realize that those are usually thousands of things every couple of years. And I mean, just this is something that we can even skip, but a really quick note: I usually try to archive these things, go from something that looks like this, the high resolution scan, to something like this, right? I take some freedom to do modifications and clean up the drawing to share online. And I usually save the scan drawing, the edited drawing, and then masks that identify where the labels are, the arrows are, and where the drawing is, right? And then from there, we can, on the web, for example, we could choose to use those masks to isolate the labels or to isolate the drawing, right? And this also has a lot of potential in the future to build data sets and, isolate parts of the drawing or manipulate them. I also have a kind of like a defined way in which I edit these things in Photoshop. I'm gonna kind of skip through this one. If you are interested, I can share more on that. And I think I have, I have some hints here on how I edit, basically like trying to make the blacks more black, and then a process that is actually a bit tedious for manual cleanup sometimes, especially when you have watercolor, because when it's black and white, it's pretty easy just to adjust the level. And yeah, so this is something that I many times have thought like ML would be a really good candidate for, right? Right now we have in Photoshop object selection, which helps me a lot with not having to do many times the selection that I'm doing right now in the video by hand, but it's still not fully there, right? And as I said before, the prints from Adobe Acrobat, I have a defined workflow where I print these things and they turn out pretty well. You cannot even tell the difference between the original watercolor and the printed one. And yeah, this is just kind of different types of drawings that we're gonna skip. And lastly, I also publish these things as a mini essay with a sketch. Sometimes it's more related between the sketch and the mini essay. Other times it's not, but yeah, there's like hundreds of these online at the moment, and you can go see them at sketch.nono.ma. All right, so I wanted to share that with you because that's kind of like the context of how I build the data set and why I usually do ML stuff that has to do with manipulating drawings, because I have my own data set and I really want to find ways in which I can not only draw analogically, but also draw with machines, right? There is one part that machines are good at doing already from before, and machine learning is making it even better. So object detection, for instance, this is YOLO. I don't even know what version. I think they're up to YOLO 8 or 9 now, but these are object recognition machine learning models that off the shelf, like a pre-trained one, because these are kind of sort of realistic drawings. It thinks that the remote is a cell phone, that the ball is a ball, spoon is a spoon, or that the potted plant is a potted plant, right? So pretty cool because, machine learning, pretty cool and scary, right? Because machine learning is starting to recognize objects and things even when we draw them. Now what we have here, even though it's a bit pixelated, is the same thing, but with a customly trained model. So here I actually trained with my own sketchbook scanned pages, and I had 3 labels. One was text, the other one was drawing, and the other one was arrow. So I can show you a few more, but in the end, the highlight is that this is something that is kind of on the works. I'm not working on this actively right now, but I can feed a machine learning model my scan pages, and they could auto crop or like select or clean up some things by themselves because it recognizes where each part of the drawing is, right? And here are some other examples, right?
What year were you working on this?
This was, yeah, I think this one specifically is like 2020, 2021. So this is kind of like mid-pandemic, post-pandemic, I think is when I started trying to do this. Some of the early things that I'm going to show now was like 2016, 2017, which is the early days of like the Pix2Pix and all that stuff.
Yeah, I'm asking because I feel like the current interest in machine learning and how it might fold impact on design and creativity um, is a different world than the worlds that you were operating in 2020 or 2016. And like because of the like the infrastructure of like what we could do has changed so much across that time. I think it's really good for students to see like get a kind of glimpse into those earlier worlds and know what it felt like to work then.
Yeah, I think, I mean, before machine learning, I think computer scientists realized they could use machine learning for computer vision tasks. That was kind of like the thing. It's like computer vision algorithms work, but it's super hard to get them right, and we have to hard code many use cases. These type of models for image recognition, gesture recognition, speech to text, and many other things have made it super accurate, and were things that already existed that were made super accurate and retrainable really easily with like a supervised method, basically just preparing a data set and training, and then you have a new algorithm working. So you didn't have to kind of hard code rules for different things. But as we can see, with like the stable diffusion and GPT and all these things, it's kind of like a general purpose tools that, I mean, if you drag and drop I believe like if you drag and drop an image to GPT, it might be able to do like object recognition automatically, and you don't even tell. You can ask things about a picture, and it's doing object recognition in the background. So yeah, so another quick note on vectorizing drawings. Many times we want to do something as simple as, well, as simple for a human, right? Like retrace a hand drawing. Like if you are drawing on a tablet, you can be generating vector data automatically. But if you're drawing by hand on a sketchbook, that's raster, and by nature is really hard to vectorize trace by trace. So there is work this is from Japan, 2021, SIGGRAPH. I tried it. It works pretty well with certain drawings. What you can see here, the heat map represents the different order of the strokes that were generated. And with some of my hand drawings, basically this tries to guess what strokes maybe I did to make these drawings, right? And that's pretty cool because it means that when these things get better, we're going to be able to get a hand drawing from like a napkin or something and animate it, or maybe try to teach somebody like the process to reconstruct that with lines, right? So now I'm gonna enter a block of projects or like studies that I have done over like this series of trying to produce or work along machines. This specific project was called Suggestive Drawing Among Human and Artificial Intelligences, is what I presented as my master's thesis at the Harvard Graduate School of Design with the guidance of Panayotis Michalatos, who is like one of I don't know, maybe he's the most intelligent person I know, probably. He's really cool, really creative, and everything he does is pretty nice. So let's dive into this. The kind of the conceptual basis of this project was that we sketch to represent how we understand the world, and that drawing software makes a tedious task trivial. Like if you think of like add drawing or like copy pasting or undo, but machines don't really participate in how we interpret the world, as they cannot really perceive it, or they couldn't perceive it in 2017 as they do now. This is rapidly changing. Here's, for example, a sketch drawn from scratch by a neural network called SketchRNN, which in effect to be trained has seen thousands of sketches of a bird that were actually made by humans. There's been a boom on artificial intelligence and machine learning, and programs can now learn, for instance, to help us continue or edit a drawing. And one thing that I try to claim with this project is that machines and inputs force us to think with discrete units of actions, clicks and commands. And this is something that, in some way strikes me that Photoshop managed to get diffusion models into a click and command pattern into Photoshop, which is really sad in some way. I mean, it works really good, but really well. But I think that's kind of like the low hanging fruit. I think what they're probably researching on the side is like, how do we make this into a new way of interaction, right? Not just with clicks and commands. These systems also tend to, when I refer to the systems like CAD system, for example, any line that you do with 2 clicks, no matter who makes it, if it's from the same coordinates to the same coordinates, it's going to be the same. It's like a deterministic translation. But actually humans are more expressive, right? Like if you tell somebody to join 2 dots, that expressiveness actually has a lot of information or on the signal that machine learning models are clever to be able to interpret differently. So this is good. I mean, this means that human input can add up to computer systems. And also there's like 2 different paradigms of interactions, right? Like one on the left, that you have a clear goal, like you have a problem to solve. You need to get out of a maze, for example. You have to trace the path. And on the right, you have a process that looks more like sculpting. Is basically every time you add a new element, you have a new object to orbit around and reevaluate, and your path might change. So it's a bit more creative. In this project, I built an iPad app for drawing in collaboration with other people and what I call suggestive bots. And I told Kyle that I should have built a website because, the iPad app really never made it to other people. And, it encoded. So this app actually encoded what I call behavior on the left, memory on the right, that is sort of like layers in Photoshop, but there was no explicit layer structure. It was like a temporal association of drawings. And I try to escape that click and command pattern that we see in Photoshop. And we're still seeing in many interfaces, probably because it's kind of like the easiest way to implement things at first. And the idea was that the same way that another person can see what you're drawing in a collaborative drawing app, this bot could grab some of those drawings and actually manipulate them in some way, right? I ideated a few different bot actions. I got to implement the first 3 on the top, like texture, continuator, and sketcher, that could be combined into metabots. And I think this is still like what some companies are trying to do, and I'm trying to do on the side to see if we can get some of these things implemented. This was one of the early demos, so I managed to finish the project with a few weeks of time in advance so I could play with it. And I actually had a lot of fun because I think that's the most rewarding, when you build a tool that makes some sort of interaction feel natural and that you want to use it more and more. The credit of the technology goes to Philip Isola and his team built Pix2Pix. They open sourced the network, this algorithm that could map from input images to outputs. And Christopher has built a web app that went viral, and that's how a lot of people got to know this. And I always talk about GANs were really viral because they were really visually appealing, basically generating visually appealing images, where some other models were maybe better contributions, but they were not having an output that was so striking to the human eye. So texture, when you use it as it's meant to be, you had one model per object type. So for example, I had a model for sunflowers, a model for roses, a model for daisies or dandelions. And this one was trained with like clothing from the Met Museum. And what you need to understand that was really different back then is that this was all supervised training. So you had a mapping of like input image to output image, and each data set had like really reduced knowledge. I mean, what's really crazy is that image diffusion models now, you don't even need to teach them about types of flowers. They already know, right? You can prompt them and they already know because everything is there in a compressed virtual space, right? And yeah, but one thing that I kind of like is that my focus with this project wasn't really on the machine learning architecture. It was more on the interaction of how you put this on other people's hands, and how the model brings back suggestions in real time without basically interrupting what you're doing, right? There was actually a nice thing that happened in this project, that is that because I was running the models on my computer through Wi-Fi, there was some latency, and those like from 1 to like 10 seconds that the output took to come back was actually a feature, because it felt that they were bots that were working at different paces, right? So you might move from a place in the canvas to another one, and then you will get images come back at an earlier drawing. And what we really liked from this project was actually when you misused it. So for example, these are all drawings that are kind of abstract shapes with models that don't have anything to do with the things that I'm drawing. And this is actually what the suggestive drawing part was, right? Like you're getting a machine learning model that is filling your drawings with textures and colors. And I think that for self-expression might add I don't know, some creativity or some kind of ideas of things that you might not have done before. So I'm just letting this go so you can see some of this. But you could see, I mean, I was just recording my screen and I was actually playing because it's actually fun. I mean, it's pretty cool. All right, so I think this is it. Yeah, and then Sketcher was a model slightly different, because the other one was trained from images that were scraped from Flickr or other places online. This one was trained on hand sketches of trees and urban scenes, and it could basically infill silhouettes of trees with what would look like if somebody had used a pencil or something to shade them, right? The credit goes to the artist, which is my mom. So my mom was in Spain while I was in Boston. She also sketches. So she sketched 64 trees by hand with ink. And we'll see the data set later. And then the bots fill these shapes. And we also had some watercolors for with other models here. And yeah, so you could create compositions and use some of these different models. This is what a dataset looks like. So for example, from the Met Museum, the things that the model actually learned to average clothing to like brown, because that kind of like tones of beige and brown is what the most of these look like. The silhouette on the left was made with an edge detection algorithm. It wasn't really machine learning. Nowadays, we could use models to make a much better data set. This was the model that was used for edges to daisies. As I said, automated massive amounts of data, not how we really sketch. And this is the edges to hand sketches, right? It's like 64 trees to their corresponding textures. And here we have the entire data set. So with a fairly small data set, if you do some augmentation, you can actually get some of these models working. And then a continuator, another model that I managed to build, which learned how to go from a tree trunk to branches to leaves or small branches, and then to leaves. So this one it was an idea of like, can we make a model that instead of infilling the drawing for you with texture and color, could like continuate the drawing for you, so you have to like go over it and then help you learn how to draw something like a tree or some other incremental drawing. Because one of the kind of criticisms of these type of projects is that if the machine is gonna do drawings for us, when are we gonna learn? Do we really need to learn to draw anymore? So it's kind of like an argument that is still valid. The kind of takeaway that I got from this is that in 2016, by creating a data set, the designer could be a programmer, and choosing the right set of images becomes part of the design process. Nowadays, we're seeing that, even just with like a piece of text, you can send that to GPT and train a machine learning model. I'm going to take a look here on the chat. Okay, I see that Kyle is sending some notes there. All right, great. So yeah, this is evolving now. I think now a designer can be part of the programming cycle just by using words or English. So this keeps evolving. And yeah, so I did some of the drawings that I showed at the beginning with this system. And I like how, in some way, because it suggests textures from what the models have learned, it makes me create some artful output of something that I might not have done on my own, right? I might not have colored the flowers that way or the textures on this drawing. And in the end, there was some sort of memory on the system which could serve to retrain new bots. I never got to do that around doing that, but I have like the database, and the database actually has all the strokes with the vector outlines and all the outputs of each of the little requests that went sent to the system. And yeah, so I think non-deterministic tools bring expected results, and as I said, this might lead to you creating things that you usually wouldn't have done. And also, I think what I like the most is if we can create tools that help kids, for example, build intuition about how things work. Like if you could allow them, not do things for them, but also help them through a process of creating.
I was just writing down that quote from I was quoting you in my notes from that previous slide. Non-deterministic tools bring unexpected results that might lead to, things we haven't thought of yet. I'm not sure. This is an incomplete thought. Is it really the deterministic or non-deterministic nature of the tool which is the most important factor? Or because I don't, that's not the first place I go when I think about like the position of tools and methods in a creative process and how they differently support different creative processes. I don't, my first thought isn't determinism in the tool. I think it's like, it's other things.
Well, are you saying that you don't think like the non-deterministic nature is what is creating something different, or?
Um, I guess I would frame it like what are the qualities of a tool which lead to practices that support practices with the creative practices with the tool, right? I mean, I think you can't you can't say you can't determine what people do with your tool. Any tool, like you have to look at not only the way that it works internally, is it deterministic or non-deterministic, what are its interfaces, etc. You have to look at it there, but also how it enters the world, the cultures of practice that pick it up and use it. And you as the author of the tool only have limited influence, right? But
Yeah, so
even looking only internally of how the tool works, is the deterministicness of the tool the most important factor, right?
I think we're now, I've reevaluated. This is, I wrote that in 2017, actually, that sentence. I've reevaluated a bit. I haven't changed it, but what I was trying to reflect there is that from a system, right? Like if you had a system where, you have a finite number of possibilities, say going from image 1 to image 2 to image 10 to image 10, right? Or something like that. Like you have like a basically where you can have a mental model of anticipation of what's going to happen if I do this action, right? If you have a system where, like AutoCAD, for example, like if I click here and click here, you already know what's going to happen. Like if you could give a command to the computer, you could anticipate what it's going to do if it works well. With a data set like this, the power was that with 400 images of flowers, for example, those flowers in some way are existing combinations. But if you train the model like this, the model actually learned some patterns that the outcomes from what you're going to get from an input to like an output image was unexpected to you, right? So it might lead you to like new combinations you hadn't seen. Now what I see is like, in some way, what's happening with GPT and Stable Diffusion is that the models are actually quite deterministic if we were able to know everything that the model knows, right? Because it's basically we can understand it as a database of things, right? There is like a database of things, And if you have a prompt, you could, if you have like a million data points on your brain, you could kind of know what it's going to say, right? So I guess more than deterministic, non-deterministic is like that the system can bring things that you haven't seen before or that you wouldn't have imagined as an outcome for what I was doing in this specific project, right? But yeah, I don't know. I mean, let me bring back that quote. I want to actually understand. I don't know if I fully understand your.
I think in the creative sense, whereas what I understood from Nono's sentence is that as humans, we think that computers are able to process all this information quicker than we do, but our creative process is so much faster and fluid and non-deterministic than machine learning systems because they all have fixed data points, which they go back and forth and relate and predict and do all the algorithmic things. But our brains and our systems and our creativities are ever evolving and unpredictable, and they come from different places and experiences. So maybe it's that creative juice that is the non-deterministic.
Yeah, I think, I mean, yeah, I agree. I think I'm not sure if you guys are familiar with like the concept of temperature on like a machine learning model. Kyle, I'm sure you are. There is sometimes where if the temperature is like, I think it's like super high, right? You kind of know what the result is going to be. If you put like a circle that is orange and you say at an orange on a table, you kind of can guess that there's going to be an orange there. But when you change the temperature value and you get farther away from like what's expected, then the model starts making up things and not take too much into account what you are asking for or something, right? So I think that's what I mean, like the possibility that a model could create something for an input that you've given that wasn't what you would expect, because it's kind of like a surprise factor. But I'm not sure that leads to creativity. It definitely leads to you seeing things that you might have not expected.
Well, so we could go. I'm going back to like Donald Schoen's description of creative practice, which is you you're in a problematic space, you make a move, right? You externalize this move into some representation, and then you look at that representation, or you kind of observe, and then you see something new in this representation, and that you can respond to and change. It wasn't something that you intended, right? It wasn't a description that you intended to put in the work, but you find something new that you respond to. And that iterative, like make, see, make again, is like a generalized description of creative practice for Schoen. And so here, so that supports your statement that non-deterministic tools are good because there'll be something extra in that world that you've made, right? That you can then see and respond to. And that new thing is good. It's a chance to like find something that you wouldn't have found otherwise. But I think it's about balance if you want to describe it in terms of determinism, because, okay, here's my counterpoint. Midjourney, so you're saying that these are deterministic. I see it the other way. I guess it depends on the implementation. Midjourney for a while feels like a roulette machine, right? Like you start with a prompt and then it gives you these 4 images and then you just click on one, right? Or you're like, roll again. Oh, one more time, maybe it'll get better, right? And your sense of control is really distant in that way. It's like, if you're lucky, you'll get something that that works for you, but there's not really a way to act on the thing that it made in a meaningful way. And so that's non-determined. Is it deterministic? Is it non-deterministic? I'm not sure. But what I miss is the property of like meaningful control, or the right balance of control. So I think it's impossible to develop a kind of craft-like relationship with a system that you don't have, where your actions don't have meaningful and controllable, predictable results, right? You can't develop a craft in that context, but you don't want total control. You want a little bit of messiness, right? So I think it's about balance, I guess, what I would argue.
Yeah, I would say, don't interpret me wrong. I didn't say Midjourney or DALL-E or say are deterministic. I said like if you use some of these tools with like the temperature really high,
Yeah.
you can learn to kind of second guess what they're gonna do, right? Like, and what I said is like, this non-deterministic nature is because we as humans can't really predict the numerous amount of possibilities. But I'm sure that there's a way where, if a model analyzes the other and they both generate, like, have to guess what the other has to generate, they can guess it in some way. I don't know. It's basically that there is non-deterministic nature because machine learning is fuzzy. That's by definition. But if you have a really small, for example, like a self-contained pix-to-pix model, you could actually sample the space, and by sampling the space, you've kind of guessed all the non-deterministicness, and then you have a kind of like a lookup table of like everything that's going to be generated from that knowledge, right? Okay, so one of the experiments I did, and you can see there is like an evolution from pix-to-pix models that were the first GANs that appeared. This one is using a style GAN that is kind of a more developed, was able to generate a lot like better quality images. The kind of the benchmark was always generating faces, and I call it hallucinating sketches. Hallucinating, usually I think in like language models, when the model makes up something that you like, it's like you call it that is really creative, and when it makes up something that you don't like, you basically say that it's hallucinating. It's like kind of bad connotation, right? In this project, because I have this data set of drawings that I showed before, with many of my hand sketches, I fed some of these ones, and then generated this. So if you look at it from afar, they resemble a lot the composition and the kind of aesthetics of my drawings, but they're not, right? When you zoom in, you see these really weird shapes that, I wouldn't call this a successful experiment in some way, but it's kind of what the model could do at the time with the data set that I had and with the resources that I had, right? Even though I could kind of cherry pick as a kind of a human curator, these were the ones that resembled a bit like structures or buildings. And then I could do a latent walk on some of those. So it's kind of like a morphing between each of these ones. You can see like annotations popping in different places, some things that might look like arrows or different text. It's not legible, but that's kind of like what the model seemed to have learned, is that the pattern that sometimes on the top right, on the middle, or in some areas I put those tags. And these ones, I don't know, I call these paper bags. I don't think like it is cardboard bags or something. I don't really know what it is. But we also did a latent walk on this, an interpolation. And you can see again the composition with like these little labels that appear. And here are some of the synthetic images kind of like selected. This might look like a building. This one seems like a bottle of cologne or something. I don't really know. And some other artifacts. But I like how, for example, in this case, we see two different items, and each item seems like it has some labels of its own, kind of like center text, as I like. And then I also made a latent walk on some of my mom's pencil portraits. This is pretty funny because I can recognize perfectly the the 3 or 4 people that are actually in the drawings, but some of the times are kind of like a kind of hybrid remix in between some of us, right? So this is some of my experiments on StyleGAN too. And then this is also StyleGAN. So using the same data set, we could see like edges on the left and daisies on the right. There is a third kind of model that basically what, let's see how I can simplify this. In pix-to-pix, you had an input image, and then you had an output image. In StyleGAN, you actually had an input of vector called Z of like 512 components, and you will get out an image. So some people made a model so you could get an input image, encode them into a Z vector that you can then input into an existing StyleGAN model and get the closest image to that encoding from the StyleGAN dataset, right? Or like an interpolation. So we can see this is basically a prediction of pix to pix. So we have the input on the left and the predicted image on the right. This particular example is pretty good. And then basically what we would like here is to input the image on the left to this model and get the image on the right from the StyleGAN model, right? These are some of the images during the training process, so you get a bit of an idea. And then this is a latent walk or an interpolation of the StyleGAN model when we train it on those flowers. Let me see. Oh yeah, okay, so it comes. Yeah, so basically here what I have is like a different type of model. We try to basically get from this image into simplified images, sketch simplification, so we can use that for training instead of using images that look more like this one. You see this one has more artifacts. So what I did there is that basically you could input these photos, and with a Python script, you could get the things on the right. And that actually is basically using machine learning for computer vision in a way that works better than traditional computer vision methods, right? So this now is me making a hand drawing and getting the prediction from the StyleGAN model. So I don't have any diagrams to show here, but there's like three things going on here. There is an image that is my drawing. It's being encoded into a vector, and it's being input into a StyleGAN model, so we can retrieve an image from there that should resemble the thing I have on the left. What you can see here is that if the StyleGAN model doesn't contain the information for the image that we have on the left, it's just gonna retrieve the thing that resembles the most, but it's not matching completely. Pix to pix means basically there is like a pixel to pixel relationship. Here we go from image to a vector, and that vector retrieves an image from the latent space, which is not exactly the same. We could make this work so much better if we have a huge data set, maybe with synthetic flowers generated with CGI or something. Then every single drawing that we make on the left will have a really close image to it on the right. So this will work really, really well in that case. This method has rendered pretty useless now, because with Stable Diffusion and ControlNet and things like this we already get for free. Probably also because of what I'm saying, that there's a huge data set that has almost all the possible combinations of photos, and probably also because the way the network works does a lot of data augmentation, so it doesn't really matter if the images were not on the original dataset. And then lastly, I've talked a lot about manipulating or like processing raster drawings with machine learning. This is work from Google Brain, David Ha and Douglas Eck, on something called SketchRNN. It was trained, I think, like almost 40,000 hand sketches per class or per type of object, like cat or angel or sofa or things like that. And it's a bit crazy because it needs too many data points to be able to do this, right? So what we get from there is that we can ask the model to generate a drawing from scratch, like a bird, or we can actually start from a circle or some shape, and it will try to autocomplete according to context on how it's seen some of these drawings before, right? So in here, I think I'm starting from that box drawing, and then the bird is doing those different combinations. And here you see the initial circle is kind of fixed, and I'm asking the model to give me different possibilities of how to autocomplete that drawing in vector form with my input as the start point, which I think, I mean, this is pretty cool. And when this gets better, the thing of these models is that because they're vector, the amount of data that they work with is super light, and they can perform like, I don't know, I wouldn't say like 1,000 times faster, I don't really know, but a lot faster than image models, raster models. And this is what a vector would look like. Basically, you have the delta, like what you've moved the mouse, and X and Y, and then P1, P2, P3, whether like the mouse is down, whether you've moved, or whether you've moused up. We have that here. Yep. All right. Real-time interfaces. And yeah, and just a note of something that I can demo now. I kind of retrieved this from the archives, and now I realize it works a lot faster. This is interacting live with a Pix2Pix model on a web tab. So kind of what my master's thesis did, but ported in some way to working on a web tab through API requests. And this one is me yesterday doing a live stream trying draw fast, something that I believe Kyle has shown you already. And I also had a lot of fun. I had to kind of draw flowers to kind of for completeness on this presentation or the kind of the project. But I'm really surprised because in some way it also allows us to do a lot of kind of drawing on the side or drawing directly on the thing. Doesn't do one-to-one mapping in this example, like matching where things are like pixel to pixel, but it's pretty cool. I mean, I have some other experiments that I can also show. And yeah, so I had this sentence there. I wanted to put it. It meant something before, but now instead of one line of code, we have no code. So you can actually train now models with user interfaces and get a completely different program without even know how to code. So it's pretty hard to kind of follow up with the industry, because even if you learn a lot about the internals of machine learning, as a user, somebody who has never coded in their lives, now they have access to like the latest of the latest models of like language models or image generation. So it's getting interesting. It's getting democratized in a way that anyone can use it. But I think there is still a lot of power into like choosing a niche topic and actually try to play with these models at the low level. So for example, fine tuning, maybe today could be fine tuning stable diffusion or retraining large language models. I think that's it for my slides. We can go back to any of them, or we can take a look at other stuff. I have links there for some of the things I mentioned, and I can add more if I forgot some of them. Thanks a lot for your time again. I think I went a bit over, but I hope that was good.
That was fantastic. Thank you. No, we'll do, I don't know, I think I can push a button here which says, there you go, the clapping button. Awesome. There's some questions I would love to come back to that were in the chat from the group. Let's start with Vidit.
Thank you so much. Thank you so much for the talk, Nono. This is really amazing. It is the kind of work that I am also really interested in. And for me, what I'm really interested in is the interaction models it unlocks for the touch-first devices. I'm seeing a lot of sketches turn into drawings, and I've been prototyping with design tools where I could probably create a low fidelity wireframe and turn that into a high fidelity mockup with interactive tools, with interactive components. And I'm curious, like, if you've explored that area a little bit, and if you see value in retaining the original sketches by the designers, so that they can sort of see how their sketches are turning into high fidelity mockups. Is that something that you've explored while working on these ML-based tools?
So you mean you're building is it a web app or like a tablet or something application?
It's an iPad app.
An iPad app. Okay, so it's an
Yeah,
iPad
yeah.
app, and you're trying for people to have an input with their pencil, for example, and then do some stuff
Mhm.
with machine learning.
Yeah.
Yeah, so I mean, in the project I did, and every time I work with like vector data, basically with an application on the digital world where you're drawing. I always see a lot of value on data gathering for like, like getting the actual, you can get like the vector data of the traces that they did. You can associate them by time. You can even get the timestamps of like when each vertex was created. So you can later reproduce exactly. I think that's what I was doing. Like you can actually replay the sketch at the same pace or maybe 2x or 3x of what they did it, but you can see where people actually stopped and when they continued and all that stuff. And having the vector data might allow you in the future to work with the same data as a data set in a different way that you haven't thought today. So yeah, capturing, I mean, for me, capturing the input, the raw input from the user and the manipulated input and the output all the time together, I think is really valuable.
I think Monica's question might be related.
Yeah, I was just curious because, like, I feel like, there's only so many times I can draw insulation in a wall or like putting in mullions and like having to do that. And I just wondered if there was a way you could generate, like, knowing that you have these like recurring conventions that come up, like with object detection, like if there was a way that you could generate, even if it's hallucinating, like um like these different elements, like training, like using training models to, or the data set to like produce wall or plan details, or I don't know.
Yeah, I mean, that kind of, I think that's where the project I did started. The premise was like trying to autocomplete like textures on like when you're like doing floor plans or like facades or things like that, like the trees, you already know what the tree you want the trees to look like, or the textures of the floor, or like the concrete or things like that. So yeah, that's, I mean, that's where this project started. The problem is that back then I didn't really have any resources to work with like vector data, so it was all like image based. Now there are a bit more models that work with vector data, but I think it's still an area that is not super explored, like auto-completing drawings in the vector space. I think this is where everyone's trying to innovate, and I mean, whoever gets it right, it's gonna have a lot of success, I think. But I mean, you're touching on a really important thing. Is basically like the tedious work that nobody wants to do on like on AutoCAD or Revit or things like that, and how to autocomplete or do pattern recognition. I haven't really worked on a project that seems like a meta project. It's like a project that is following you while you're drawing, is recognizing some shapes, and it might tell you, okay, you've done two like lines like this. Do you want, this seems like a insulation panel, do you want me to fill it? You know, it's kind of like more like an agent than a specific model. More like it's basically like a meta bot, right? Like it's kind of coordinating with you and trying to second guess what you're doing. Maybe it asks you like, are you trying to do this? Do you want me to? I think that's the way that it should. I mean, that's the thing. Like there's the two patterns that I mentioned before. Like you can have the pattern where we'll get before. It's like you do two lines and then you select the lines and then you go to a command in Revit or a command in AutoCAD or something like that, and you say, fill this as a insulation wall or like a structure wall or something like that, and then it will do the magic. I think the next step is when you're actually drawing and it already knows, it guesses what you want to do and it asks you without you having to like be telling it what to do all the time. And as I told Kyle yesterday, I think, or 2 days ago, this is where innovation can happen, because everyone is building the models, and basically it's like we need to tell the model, have this input wall, I want to do this, do it for me, right? But the next step is like, how do we build interactions where you can maybe tell the application, no, I'm building a wall. You can say I'm dimensioning, or I'm detailing furniture, and then the model starts helping you out in that area.
Yeah, this touches on one of when I'm evangelizing ML in design, one of the things that I talk about is like for the quote I go back to is like, for the past 60 years in computational design, you know, people or designers have been kind of taught or insisted we've had to think more like computers, and isn't it about time that computers thought more like us, right? So like the most exciting thing about ML and design is that we can finally kind of unwind all of the sort of non-humanness that's been baked into CAD systems. We have to do so much data entry and like stuff that's got nothing to do with the kind of creative active design. Would like this offer, these kinds of systems offer us the possibility of kind of extracting the dumb stuff out of like our work as designers. Lots of expressions of thank yous and appreciation. No, this was beyond my wildest dreams. This was so great. Thank you.
Thanks a lot, everyone, for being there, as I said, and thanks, Kyle, for inviting me.
Well, so my pleasure. Okay, guys.
Bye.
Thank you. Thanks again, Nono. Take care.
Bye.
Thank you.
Nice seeing
You.
you.
Thank you.
Bye bye.
Thank you
Thank
so
you.
much once again.